let's start. So welcome everyone. We're going to be talking about Monitoring 101 with Windows and PowerShell. So a little bit about me. I'm Matthew Hodgkins. I'm a principal engineer at an e-commerce company in the Netherlands. And one of the things I do there is help developers instrument their applications and monitor their stuff when it's deployed to production. So I'll be sharing some of those lessons with you today. So here's a look at our agenda. So why is monitoring important? Why should we be doing it? What does bad monitoring look like in a company? We'll cover some basic concepts around monitoring. Then we're going to have a look at a tool called Datadog. We're going to apply the concepts to Datadog. And then we're going to have a demo of monitoring Active Directory using what we've learned. And then I'll show you some good examples of monitoring from inside our company. So first of all, why is monitoring important? Why would you want to spend time on doing it? So we all know that downtime costs are pretty much growing. So if your business is doing well, you're getting more customers, or you're doing more important things. So if you have downtime, you're going to have people that are upset. So they're not going to be happy that things are down, and you're potentially going to be losing money. So knowing before customers do that things are down is pretty important. We've heard a lot today about moving things to the cloud or cloud architectures, cloud infrastructure, and things become a little bit more complicated when things are in the cloud. You can't just remote into a server anymore, look at event logs, and see what's happening with the machine. Some things are running in the cloud. You don't have access to them. It might be serverless. So monitoring these things becomes more and more important. And the other one is just be a bit selfish. Who wants to be woken up at 3 a.m. Because of backup drives filled up on a database server or something? If you would have known that before time, you wouldn't have been woken up at 3 a.m. So be a bit selfish when it comes to monitoring stuff. So how do you know that you have bad monitoring in your company? So from an application perspective, if your customers need to call you to tell you that the thing they're using is down, well then it's a pretty good sign. If you have applications or services running that where there's no alerts defined, again, pretty bad sign. If you have so many alerts defined, so you actually are doing monitoring, but you have so many alerts defined that you get alerts popping up and you say, well, that always happens every Tuesday, so forget about it, doesn't matter. Or you have dependencies of your applications that are unmonitored. So you might be dependent on a database server or a web server, and you're not monitoring those from your application. Then your monitoring is bad, and you should feel bad about it. Now, from a sort of an infrastructure perspective, if you need to create tickets to have something monitored, so you build a new server and you've got to make a ticket somewhere so they can add it to the monitoring system, or you're logging into servers still and looking at event logs and log files on disks, or pretty much anything. If you're having to do anything manual to get your stuff monitored, then your monitoring is bad, and you should feel bad. So let's go over some concepts. There's a couple of monitoring concepts that I want to touch on. But pretty much the whole point of this whole monitoring thing is finding out the businessy thing. You have an application. What's the businessy thing it's supposed to be doing, and is it doing it right now? That's the whole point of monitoring. So these are the concepts we're going to cover. We're going to cover logs versus metrics, causes versus symptoms, golden metrics, so the metrics you always want to go after first, how to measure your dependencies, and defining service level objectives. So you heard Steve this morning talk about SLAs, SLOs. We're going to cover what those look like. So first of all, metrics. Metrics are really good for trending things over time. So pretty much it's a single point in time, like a CPU usage. You measure it at a time, and you trend that over time. Metrics are really good if you want long retention. So in Datadog, which I'll show you a little bit later, you can store the metric information for 15 months. So you can go back 15 months, see what's happening over your infrastructure over time. And metrics really give you smarter alerting, which I'll show you in a minute. But pretty much a metric is just a single measure of something happening at a point in time. Whereas logs, on the other hand, they give you a lot more flexibility in what you can store. We've all seen exception logs and stuff like that. It's very verbose in what you can store. And they're really good for troubleshooting things. So diving in and finding out what's happening with the application, why is it broken right now. It's also good for auditing, so finding out did a user do a certain thing at a certain time, what are the things they've changed, what are they touching. And it's really nice for correlation IDs. So say you have a process where someone makes an order, you can follow them through the system as they touch different systems in your infrastructure, and just follow them through a transaction, for instance, and find out what's happened. So this is an example of a metric in Datadog. We have Redis net commands, so how many connections are coming into Redis, and this is the metric trended over time. Actually, I'll go back one. These thresholds up the top here are defining what the alert is. So if that metric pops out above those lines, well then that's an alert. So this is one example of alerting on a metric. This is a different example, so you can get a little bit more advanced. And this is anomaly detection. So the same metric here, if it drops outside of those gray bands there, you know that there's an anomaly in this metric. So based on its history, it should be in these bands somewhere. And if it pops out, well, you know there's something going strange. Whereas when you have logs, this is Splunk, another really nice tool that we use for logging. You really only have some basic ways you can alert on this. You can say, well, are the logs there? How many logs were there? Or if there was no logs, sort of send me an alert. So with metrics, it really, you can do some advanced things with alerting. With logs, not so much. So what you should do is combine them where possible. So the metric should tell you there's something going wrong right now, and the logs are there to dive in, figure out what specifically is happening. The next one is causes versus symptoms. So causes are pretty much based on a technical thing. So the CPU usage was 100%. That was the reason the server wasn't working, something like that. Whereas symptoms have more basis in the business. So nobody could generate reports anymore, as an example of a symptom. The thing with causes is that there's so many potential causes. There's always going to be new causes happening. A change was deployed. A Windows update was installed. The disk was full, the CPU was full. There's going to be millions and millions of causes, and you're never going to be able to catch them all. So what you should do is alert on the symptoms instead. So add metrics to all the potential causes, the CPU usage, the disk usage, your network latency, but alert on the symptoms so you can always catch that something is broken. And this pretty much helps you reduce your alert fatigue. So instead of having a dashboard with thousands and thousands of potential things that can break at any one time and you start to ignore things because it's always like that, really focus in on what are the business things that are happening in my business and are they healthy right now. So here's an example. Here's a very complicated process that you have. And say this is an ordering process. You have an e-commerce website, say, and people are placing orders, and the order needs to flow throughout this whole system and move into the database as an order's being placed. Well, the first thing you might think is what I'll do is I'll instrument all these machines, all these applications. I'll put alerts on absolutely everything. So if something breaks in there, I'll know it. And then that's where you fall into the trap of alert fatigue. You're going to just have so many things going off that you're going to get sick of it. Whereas if you put an alert right on the end there, right on the database, and say, well, if nobody's made an order and no order has been placed into the database in the last, say, 5 minutes, well, then there's probably something wrong with this entire order flow pipeline. So that's the difference between alerting on causes and alerting on symptoms. Now here's some good examples from internally. These are the alerts that were originally defined, and here's what we moved to focus more on the symptom instead. So this first one here is number of PHP processes was over 100. So it doesn't really tell you a lot about anything. Like is that per server? Is that added up in total across all the servers we have? Whereas the better thing to be alerting on there is the search success rate is above 99%. So they were alerting on a cause at this point. So PHP may have been a cause for searches to fail. But if we alert on the symptom instead, we're always going to catch that something went wrong. Another one here. So MS SQL CPU usage is over 90%. Well, what if we have 100 SQL databases doing load balancing? Do you really care that one of those is at 100% or 90% at 3 a.m. in the morning? Not really. It doesn't matter that much. Whereas what matters is that the product page is loading with, quicker than 2 seconds for 95% of your customers. So that's changing alerting on a cause and alerting on a symptom. So when you start instrumenting an application, you want to start with some really basic metrics. And these sort of help you define which metrics you should go after first. So the Google SRE book says that latency, traffic, errors, and saturation are the things you should go after first. There's a use method, so utilization, saturation, and errors are the first things you should get first. And RED, which is the rate, error, and duration. So rate is how many things are happening in my application right now, how many errors are occurring, and how long are those things taking. Most monitoring software is going to have the concept of metrics, and there's different types of metrics in monitoring systems. So the first one is a gauge. So it's sort of like a speedometer. It can start at 0, it can go to 60, it drops back to 20. And you can think of like a CPU usage percentage. That's a gauge style of metric. And then you have the counter. So I'm sure you've all seen this before, but these traffic counters here it's a counter metric. So it's always going up. It's just getting incremented all the time, or it's going down at a rate all the time. So that's a counter style metric. And then you have a histogram. So this measures response time. So you can see here, this is a graph from Datadog, and we're sending a histogram metric. And one of the cool things is it'll work out what's the average response time, what's the 95th percentile response time. So the 95% of responses are happening within this time, and the maximum response time. So histograms are really used to measure latency of things, or how long something is taking. The next one is dependencies. So pretty much every application is going to have a dependency, whether it's a web server, a database, a disk. Applications are going to have dependencies, so you should be measuring those things. And measure it from your application's perspective. And the reason is for, how many times have you been in a situation where someone says, well, your service is slow? Well, what does slow actually mean? Do you have any data about why it is slow? And this is why you should always measure things from your application's perspective, because it helps the conversations with others. If you're dependent on a database team or a network team, you can give them real data and show them what's happening with performance. Service level objectives. So we've talked about metrics. This is what a metric looks like. Setting a service level objective sets a target for what that metric should be. And then the next level above service level objectives is service level agreements, where you agree, you have a contract with someone, the metric will always be in these ranges. So that's service level objective agreement is the next level. But pretty much it's all about just setting expectations for your service. How should it be performing? All the applications that you run should have a service level objective or a couple of service level objectives defined. And you should really try and base those on the golden metrics, which we went over just before. So the error rate, the latency, and the rate of things happening through your application. And ideally, you should be discussing those with your stakeholders. So who are the people that are depending on this application? Set some expectations with them. What do they expect of you when you're running this application? So that's the concepts. I'm going to take a drink now. Okay. All right, so we've covered logs versus metrics, when to use which. So ideally, just use both. The metrics should tell you that something's broken. The log should tell you what is broken. Alert on the symptoms instead of the causes, and this is how you reduce your alert fatigue. The golden metrics, what you should instrument first when you're starting to measure an application. Measure your dependencies from the application's perspective, and define service level objectives for your applications. So let's talk about Datadog. We're going to apply some of the concepts to a tool called Datadog. So Datadog is pretty much a cloud-based monitoring tool. It's a single installation binary, so you just one exe on Windows, you install that, it'll start monitoring your server, and it'll send all the data to the Datadog cloud pretty much. It offers dashboarding, alerting, metrics, logs. It does a lot. And I really like it just because it's super simple to get started with. And it's also free for up to 5 instances, so you can install it on 5 servers and start to monitor those things. But you might be thinking, these monitoring concepts are all cool and all, but I run an Active Directory on premise. I don't have developers. I can't really do any of this stuff. Well, that's why I wanted to use Active Directory for this demo, because we pretty much all have Active Directory running in our infrastructure. If it goes down, we're all going to have a pretty bad day. So it's an important one that you can apply monitoring concepts to. So let's have a look at a demo. The first one is just going to be installing Datadog. So I've got a Windows server here. We're going to install Datadog on it, and it's going to start sending some stuff to the Datadog cloud. So this is what Datadog looks like. I'm just going to go into integrations and agent over here, and I'm going to choose the Windows agent. And I'll just go and copy the link for the exe. And then this is my Windows server. It's running Active Directory. I'm just going to go and download the Datadog agent. Okay, the agent's downloaded. And then I'm just going to run it. And all I'm going to be asked for here is an API key. And that API key is used to link this this server to my Datadog account. So someone remind me just to change that API key a little bit later. So I'm going to put the API key in. It's going to install Datadog, and that's pretty much it. So now what I'm going to do is just check that the service is running. So I can just do a get service there, check that the agent's running, and that's pretty much it. That's Datadog installed. If I switch back over now, I can have a look at infrastructure and my infrastructure list. And in a second, that machine, I'm running it on AWS. It's an EC2 instance, so it just popped up the top there. And I can click on that and just get some sort of basic information about the machine. So that's pretty much getting a server installed with Datadog. Okay, so let's start monitoring Active Directory. So firstly, we're going to start with some basic system metrics like CPU and disk and that sort of thing. And we're also going to start monitoring some Windows services. And this is going to give us some basic potential causes for why Active Directory might be playing up right now. The cool thing is, with Datadog, as soon as you install it, out of the box, you start getting all the basic system metrics already. So let's have a look at that. All right, so if I go back over to the infrastructure list here, and I click on the server that I installed Datadog on, you can see there that when it loads, you can see that it's been collecting system metrics from the server since it's been installed. So you have things like processor queue length, the memory breakdown, disk usage, all sorts of things. So straight out of the box, you have the metrics, and you can zoom into the time. You can zoom into the specific point of time where something's gone weird, and see the metrics, all the metrics at that point in time. Okay. So that's getting the basic system metrics. Now the next one is starting to monitor Windows services. So in this demo, we're going to connect to the Windows server, and we're going to modify the configuration file for the Datadog agent. So it's a YAML-based configuration file. And then Datadog's, with that list of services we give it, it's going to poll the Windows management interface and find the status of all these services, and then send them over to Datadog. So Datadog out of the box has a ton of different integrations, and here's one for Windows services here. And it pretty much says you go to this YAML configuration file, go and enter the list of services you want monitored. So we're on the server here, and we're just going to go and edit this configuration file. So we'll open VS Code, and there's a list of all the integrations that are installed out of the box. And the one we're looking for is the Windows service one. What we have to do is just rename this example here to just remove the example off it so the Datadog agent picks it up. And then we're going to go and find a list of Windows services that we're going to want to monitor. So we're just going to open services.msc and have a look at some services that we're going to choose. So maybe the Active Directory domain service is probably a good one that we monitor. We just grab its short name, and I've chosen a bigger list of services there that we're going to monitor, including the all-important principal. We definitely need that running on a domain controller. So we're just going to restart the Datadog agent now, and that'll pick up the changes. And then if we go back over to the interface, we can start to see if the services have started to be monitored. So we can just have a look at the checks in here. You can see Windows service state, and all of the services that we just added to that list are now being monitored by Datadog. But this isn't a very good view of them. It's not really good to come in here and click. So what we're going to do is make our own dashboard here and start building out a dashboard for Active Directory. So we'll create a new screen board, call it Active Directory. And now we can drag on a check status widget to the dashboard and start visualizing these Windows services being monitored. So we'll choose our service name from the list, so they pop up all in here, all the things we've monitored, and give it a nice, pretty name, and click Save, and then we have the status of that service starting to be monitored now. And I'll do that for the rest of the services on that machine. So we've got all the service statuses there, and let's go and stop a service and see what happens in our dashboard when we kill a service. So we'll go and just kill the principal service here. And let's see what happens in our dashboard in a couple of seconds. Okay, so you can see that the principal has just gone to critical because the service has been stopped. And now if we go back and start it again, in our dashboard it should update and everything should go back to normal, as we can see there. So that's monitoring Windows services with Datadog. Okay, so let's start to get a little bit more advanced and define a service level objective. And I wanted to go after traffic, so how much traffic is hitting my domain controllers. The thing I wanted to measure here was the amount of LDAP searches that were happening per second on my domain controller. So how are we going to get that? Well, it turns out Datadog has a really nice Active Directory integration, which collects a lot of basic metrics for you out of Active Directory. So all we have to do is go and modify the configuration file again and just enable the Active Directory integration. So this is the Active Directory integration here. And I just did a search for LDAP on this page, and there's a ton of different LDAP metrics that the integration is going to grab out. And it's pretty much just going to use the Windows performance counters or WMI to pick those out. It's just given a nice wrapper with their integration so you don't have to find them yourself. So I just go in here, I've renamed the configuration file and reloaded. Now this is the metric explorer, so all the metrics coming in to my Datadog account. You can see there that LDAP is one of those metrics that's coming in. Now, of course, we need to add this to our dashboard as well. So we'll go back over to our dashboard. And we're going to drag the graph widget down, and now we're going to choose the metric, which is the LDAP searches per second, and add it to the graph. And you can see that that little blue line is how many queries per second are happening against Active Directory. We'll again give the graph a nice name there. And now we want to see a bit more spikes occurring on that graph. You can choose different ways to visualize your lines. I really prefer the bar. If the metric's not happening a lot, a bar graph is a little bit nicer way to see it. But you can see we're getting very few searches per second, so 0.06 searches per second. So let's use a PowerShell script to attempt to authenticate against Active Directory and try and generate some more metrics. So you can see it's just starting to spike up a little bit, and pretty much all the script is doing is once a second, it's just trying to authenticate with a user, whether incorrect or not, to Active Directory. So you can see about one search per second. And if I go and modify my script here and just reduce the sleep that the script is doing, so I'm going to just change that to 0.1 sleep, we should see that metric spike up quite considerably. So you can see it's a lot faster at attempting to log into Active Directory now. And now in a couple of seconds on the graph, you'll see that spike up. And there you go, about 60 LDAP searches per second happening against Active Directory. Okay. So the next one I wanted to go after was the login success rate. So how many successful logins are happening against my domain controller, and what's the success percentage? So if I see only 2% of logins are successful on my domain controller, I probably know someone's trying to brute force it. So we want to keep an eye on that. So let's try and get the error rate. The problem is there's no built-in counters for this. There's no way that Microsoft exposes to get this information out of Active Directory. But what they do expose is two event logs. So you've got the 4624, which is an account logging in successfully, and 4625, which is an account that failed to log in. So how are we going to get this information to Datadog? So of course, we're going to use PowerShell. So finally, I'm going to talk a little bit about PowerShell, this PowerShell conference. So what we're going to do is use a protocol called DogStatsD, which is based on a StatsD protocol. But pretty much what we've seen so far is the Datadog agent reaching out into WMI and performance counters to pull information in. But we can also send data to the Datadog agent, which it converts to metrics. And the way it works is you send strings that look like this, so Active Directory.login events, and we send the count, so 23 events. The C is the count metric that we talked about before. And then we send a tag, so event ID 4624 or 4625. So we pretty much need to write a PowerShell script to get get this information and format the strings just like this, and we send that to the Datadog agent. So this is the script. I don't expect you to read it all, but I'm pretty much looking for those two specific events. I'm doing a get win event and I'm counting every time I see one. And then I'm building this string that I mentioned before and filling in the values. And then I've got this little function here, so send UDP data, and it's just sending to localhost on port 8125 and just sending that string. And I pretty much just need to schedule this to run every minute or every 5 minutes or so, and it'll start to send those metrics into the Datadog agent. So this is the demo, and this time we're going to have a PowerShell script. You'd probably run this as a scheduled task. It's going to collect all the event logs and then forward them over to the agent. Okay, so I've got the script running there for a while. You can see the strings that are getting built and what it's sending over to Datadog. And let's go and add this graph to our dashboard. So if I look in that list, you can see that the login events has popped up. So I didn't have to do any configuration for this. I literally just had to send that string to the Datadog agent. That's all I had to do, and it starts appearing in Datadog. Now, if I slice it by event details, if I mouse over it, you can see there's successful logins and there's failed logins, which are coming into the graph there. So this is the event log by the details, which is pretty cool. And then you can see the difference between how many successful login attempts versus how many failed, which are coming from that previous script that I had. But we said we wanted to get the percentage rate of login percent success rate. So we can do some maths. Hopefully you remember your high school maths about how to figure out a percentage. But pretty much we're going to first add the failed login attempts as a metric. Then we're going to add the successful login attempts as a metric. So there's two metrics on one graph now. And then we can use a query here, or a formula. And we're going to say, we're pretty much going to go the successful divided by the unsuccessful plus successful times 100. And that's going to give us our percentage success rate logins. We'll switch it over to bars again. And there you can see out of 100, there's the login success rate. The other nice thing you can do is if you have a service level objective for this, say we want 95% of logins to be successful, otherwise something bad's probably happening, you can put some markers over your graph. So you know if on the graph if it's dropped below a certain percentage, well, someone's probably brute forcing your Active Directory. So you can add the marker up there and give it a label. So 95 desired login success rate. Click save, and there we go. We have the percent rate of logins on our dashboard. And we'll go in and give that a pretty name. Okay, so you pretty much have endless options with this. When using PowerShell and this method of getting metrics into Datadog, you can literally do anything here. So maybe you want to have a script which counts the amount of domain administrators and send that as a metric. And if someone adds themselves to the domain administrators group without you knowing, you can get an alert saying, hey, there's a new domain administrator being added. So you could track the DC diag errors that are occurring. So you can run DC diag, you can capture something, send it as a metric, you can monitor those. Maybe the replication latency between your domain controllers, and even accounts getting created or accounts getting locked. So there's all sorts of different things in relation to Active Directory you could monitor just writing some basic PowerShell scripts. So the next service level objectives I want to go after is latency and saturation. So how long is it taking to query Active Directory, and how many requests are outstanding. So I pretty much found these metrics just from Googling to find out what type of metrics can I get on Active Directory. And I found this blog which listed those here. So pretty much what we're going to do again is going to modify the Datadog configuration file, and we're going to get this stuff out of the Windows management interface. So we're going to write some custom stuff to poll that. Okay. So the first thing I want to do is explore the metrics that are available to me. So I'll use performance to do that. And we pretty much go up the top and just add metrics from the Windows performance counters. And I'm going to choose the directory service as the namespace where all these things are stored. So directory services, and then I'm going to find the ATQ latency and the outstanding requests. And I'll add those across. Now, I'm not sure if you've used this tool before, performance counter, but I really hate the way the graphs, you add different metrics to it and all the graphs look really crap. So I really like switching over to report and just view the actual raw metrics instead. Now, I'm just running this on a single domain controller that, no one's connected to it, so my metrics were going to look pretty bad. So I'm just doing a load test against LDAP using JMeter, so it can create some load on Active Directory and see what it looks like. So I'll start the load test now. And if we switch back, we can see the number of outstanding requests has spiked up quite dramatically. There's a lot of things waiting, and the latency of the request, it's taking, a couple of milliseconds to actually process the request now that there's a lot of load coming through. Of course, we can also use WMI to find this. I find it really hard taking it from performance counter to PowerShell and to try and search it in WMI. I pretty much just have to Google to figure that out. So there is no nice way to do that, apparently. But then from WMI, I just go to this configuration file here. There's the class that these metrics were in, ATQ request latency and the queued requests. And then I'm converting it to a metric name in Datadog and choosing the metric type there. So I save that, restart the Datadog agent again, and those metrics will start appearing. We can do a search in the list here. So we'll search for ATQ again, and you can see the two metrics have been added. And again, similar story. We're just going to make a graph, drag onto the graph. And now we're monitoring the request latency and the outstanding requests in real time. Okay, so that's covering the SLO. So we've gotten some really nice metrics, some high-level metrics out of Active Directory. And what you should do is make that pretty, make it obvious on the dashboard, and make it so everyone can understand what's happening with the Active Directory. So anyone coming along here saying, what's this? What's this LDAP searches per second? So you can add all sorts of labels. You can add different colors here. So if it spikes up above a certain value, you can make the box red. So it's really easy to see that something's going wrong with your Active Directory. So I want to show you some examples of some good monitoring that we have internally. I'll show you the first one here, which is the application landscape. So a lot of teams have an application landscape because they look after many different applications in the company. So this particular team, they're responsible for all the orders and all the payments occurring across Coolblue. And you can see they've broken up their dashboard into different services. So you can see all the payment-related metrics are here, all the ordering-related stuff here. And all these things on the most important business metrics that we have. So you can see here, for instance, Ideal, which is like a payment provider in the Netherlands. Over a period of time, we can tell how many payments have been made to that payment provider. And if that goes to 0, that pretty much means no one's been able to pay. And we have alerts based on that. If no one pays within a couple of minutes, or we know something in our infrastructure has gone horribly wrong, and we start looking at it. You can see here there's links as well, so links to Drilldown dashboards. So we start with the application landscape. This is the high-level business stuff. And then we can click on those links and drill down into potential causes. So why is that box red now? So this is all more sort of system metric focus stuff. So how many items are in a queue, and how long is it taking to process items in the queue? So these are the potential causes for why nobody can pay anymore. The cool thing when you're doing this sort of stuff and really monitoring at this level, especially when you're monitoring your dependencies, is you start to find out some interesting things. So this is a metric of we're monitoring requests to a third-party payment provider. So I think PayPal or something like this. This isn't PayPal, but just as an example. Every request we send them, we track was it successful or not, and how long did it take. And we had this incident one day where we started seeing the error rate go up. Every call we were making to the payment provider was failing for some reason. And we called them and we said, hey, we're seeing this spike up for some reason. Is there any problem on your infrastructure? And they said, no, there's nothing wrong. And then 20 minutes later, they actually called us and they said, oh, wait, you were right. Yeah, one of the banks wasn't actually working. So when we're monitoring our dependencies, we're starting to know before even our third-party providers that they have a problem using just these methods. Super nice. So that saves the team a ton of time. So say before this, we had this monitoring. If we had this issue, customers would be calling and say, hey, I can't pay. And the developers would think, oh, they've released something and they've broken part of their code or something like that. And so all hell would break loose in the company, quickly figure out what happened. And, a lot of the time it ended up just being a third party that was down and they had no status information. So this saves us a massive amount of time when our dependencies are failing. And again, we're alerting on our businessy things. So this is the same team, and you can see the things that they're alerting on here. You don't see anything like CPU usage or disk usage or anything like that. It's really focused on the business. Successful payments in the last 5 minutes. That's what we're alerting on. So just a summary of what we spoke about. So why is monitoring important? You want to know before your customer does that something is broken. We had a look at what bad monitoring looks like. If you're having to do stuff manually, or customers are calling you that things are broken, well, that's a really bad sign. We covered the basic monitoring concepts, and we applied those to a tool called Datadog. We poked around Active Directory to figure out how we can monitor it from a higher level perspective for SLOs, and I've shown you some good examples of monitoring. So, any questions? Nope. Yep. Mm-hmm. Yep, so we had a ton of tools. So Nagios was one of them. So Nagios is a nice open source tool, but we sort of fell into that trap of alert overload. So we'd have 100, 200 Windows servers in there, each having 30 things to be monitored, and we'd be getting alerts like the page file is at 80%, at 3 a.m. Like that didn't affect anyone, didn't affect the customer. So why were we getting paged at 3 a.m. the page file size? So the other issue we had with that, Nagios is a nice tool, but it's pretty old. So doing all sorts of automation with Nagios is pretty tough. So say you have a new server coming up, well, how do you get that server into Nagios? That's a bit of a problem. And as you saw there with Datadog, you just installed a agent, and immediately it just pops up in your infrastructure list there. So we use AWS, so we have auto scaling happening all the time, and just in our base box, it's baked in there. As soon as an instance comes up, it connects to the Datadog account. So you don't have to do any configuration to get your metrics in there. So that was why we switched over. Cool. Any other questions? All right. Thanks, guys.